Hey everyone, welcome back again. I hope you have gone through the vernier caliper session and today we are meeting for doing our next experiment, that is experimental skills 2, screw gauge. So yes, just like vernier calipers, our screw gauge is another measuring device that measures the lengths up to a greater resolution. Which means, if you remember, I told you that if you want to measure the length smaller up to 1 millimeter, then your geometry box ruler will be fine. But if you are measuring the length which is lesser than a millimeter, then geometry box ruler is not a fine device. The reason is the smallest measurement, or technically speaking, the least count of geometry box ruler will be 1 millimeter. Whereas a better resolution device in comparison to that is our vernier caliper, whose least count, the smallest measurement which could be taken by it is 1/10th of millimeter, or you can say 0.01 centimeter. Yes, that's 10 to the power minus 4 meter. And if you want further resolution, which means you want lesser inaccuracy, more precise result you want, then you should be using a screw gauge. Alright, the advantage of screw gauge is that it can measure distances accurately up to 1/100 times, 1/100 parts of that of a millimeter, that is 10 to the power minus 5 meters. Alright, so first of all, our target is how to calculate the least count. So first of all, I would say let us talk about the standard one. Standard one for a standard screw gauge. For a standard screw gauge, your screw gauge is also called as a micrometer. That is also called as a micrometer. For a standard one, its least count is 1/100 part of a millimeter, or you can say 0.01 millimeter or 0.001 centimeter, because generally the options of the questions are in centimeters, if you have noticed before. Or you can also say it 10 to the power minus 5 meters, 10 to the power minus 5 meters. So basically, generally this happens, or this much is the least count of a standard screw gauge. The way we have completed our session successfully in vernier calipers, the similar way we are going to do with screw gauge, and the devices, the way you deal with them, the way you calculate the least count, the way you take the reading, almost things are similar. So any of you who has not attended the session of vernier caliper, I'll suggest you that definitely go through it, and the pattern of both the sessions will be exactly same. Today in our interaction also, we are going to firstly understand how it looks like, how to operate it. We will understand the two key steps, that is how to calculate the least count and then how to take the reading, including the types of zero error and zero correction. All right, the compensation behavior. Okay, and after that, we are going to deal with 10 relevant problem models for this year exam. All right, chaliye. So I will show it to you. First of all, how a screw gauge looks like. So in vernier calipers, there was the main scale, there was a vernier scale which used to translate. You can slide the vernier scale, and commonly speaking, translational motion of vernier scale will be a responsible motion to give you the reading. Okay. In case of screw gauge, we are going to talk about the main scale and a circular scale, and you are supposed to rotate that circular scale. So there the vernier scale used to translate, slide. Here the circular scale is going to rotate. Okay. So this is the object. Let me keep the object a bit aside right now. So the gray color scale, as you can observe, is the main scale, sometimes similar to that of your geometry box ruler or sometimes a different one. Depends on the resolution of the device. You have this circular scale. I'm holding it and I'm trying to move it. See, I'll try to move it closer. I'll try to move it away. And there is a yellow strip at the right bottom corner, like the previous interaction, which is going to tell you the reading, which is going to show you that how to take the reading. So you can see there are 3 terms over there, 3 terms. Okay. If you notice, first one, second one, third one. Third one, similar to the previous interaction, I told you, similar to vernier caliper, it's going to tell you zero error. First one will give you MSR, main scale reading, and second term will give you least count into CSR. There we used to deal with VSR, vernier scale reading. Here you are going to call it CSR, circular scale reading. Okay, stop. It was constantly rotating, right? Let's try to bring it closer. If you try to bring it close, it is going to move in clockwise sense. I hope everyone can understand that. The jaw is coming closer. The point is coming closer. Clockwise rotation will try to tight it up. Okay. And if you want to measure the size of this object, then you need to first of all see initially this would have been here. This would have been here. So if it keeps on rotating, it will come closer. You need to understand that in order to fit in the object here, we have to rotate the screw in anti-clockwise sense. If you rotate it clockwise, it will come closer. If you want to measure the size, you have to fit in the object here, which means you are supposed to rotate it in anti-clockwise sense. There is a, okay, stop. There is a line over here. That is the reference line on the gray scale, the dark colored line. And the circular scale keeps on rotating. If you notice, there are 50 divisions on circular scale. 0 to 5, 5 to 10, then 10, 15. At last you can see 45, 46, 47, 48, 49, and that's 50. All right. In one complete rotation, how much forward or backward the circular scale moves, that is called a pitch. I repeat, in one complete rotation, what is the linear translational distance traveled? That is called as a pitch. For example, in case of a spring, the consecutive turns are separated by a certain distance, that is called a pitch. In case of spiral binding, the distance between two consecutive turns is called pitch. In case of helical path traveled by the charged particle in a magnetic field, then again it is the same thing, pitch. So I'll tell you here. So how to calculate it? We will say that first of all we need to define the pitch. Pitch is called as linear distance traveled in one complete rotation. Linear distance traveled in one complete rotation. One complete rotation, obviously, of circular scale. Rotation of circular scale. Circular scale. CS. And the second step is how to find out the least count. Least count of screw gauge or micrometer can be obtained by taking pitch, that is the linear distance traveled in one rotation, mind it, one rotation, in one complete rotation, by number of divisions on circular scale. Number of divisions on circular scale. Okay. As you can see, the diagram which I have told you here, the number of divisions on circular scale are 50. So depending upon the resolution of the micrometer or screw gauge you are using, these parameters will keep on varying. And here we have already talked about the standard one. I hope the idea is clear to you. First of all, what do you mean by the least count? The least count is smallest measurement that can be taken by an instrument. So how much smaller measurement that can be taken by a screw gauge will tell you the least count of the, will be told by the least count of the screw gauge. Now this screw gauge is defined as pitch, means linear distance traveled in one rotation by number of divisions available on the circular scale that is being rotated. I hope the idea is clear to you. Keep this formula into your mind. The way I have taught you, least count of vernier caliper is always given by the difference between least count of main scale and least count of vernier scale, or you can say 1 MSD minus 1 VSD. And then you would have noticed that in every particular problem I am going to use the same. So here also this is going to be a very important and common formula. Remember this. Okay. Remember this particular formula. That is very much useful. Let me take you a step ahead. How to take the reading. There I hope you remember that reading in the vernier caliper was given by the format that is main scale reading plus least count of vernier calipers. Here there will be the least count of screw gauge. Into there it was VSR. Here it will be CSR, circular scale reading, minus 0 error, or you will say plus 0 correction. 0 error is always algebraically subtracted. 0 correction is always algebraically added. This is basically a compensation, compensatory behavior. Compensatory behavior. We will see how to provide and why to provide some sort of compensation. Why to provide some sort of compensation. Let me tell you that here. Types of 0 error. Suppose this is the reference line. Suppose this is the reference line. That is that reference line which I have already shown you. Let me show you that once again. If you see this circular scale, and I'm going to roll it anti-clockwise sense mein, I'm going to move it back. Okay. Like the reference line, the dark line you can see, the dark single line you can see on the gray scale, the main scale, that is the reference line. So if no object is placed between the gap of screw gauge, if this is the reference line, this is the reference line and the circular scale which is supposed to be rotated in anti-clockwise scale sense. The circular scale which is supposed to be rotated in anti-clockwise sense, if it's 0 coincides, if it's 0 is coinciding with the main reference line, then you will say it is starting from the beginning. It has already started from 0 reference, no leading, no lagging. In this case, you will say no leading, no lagging, no leading, no lagging. So no 0 error. So no 0 error and no 0 correction. No 0 error and no 0 correction. Now let us see another case in which this is my reference line. This is my reference line. The circular scale is this. Obviously it is supposed to be rotated in anti-clockwise direction. Unscrew it. So here the 0 is already here, down, already down. So can I say the 0 is supposed to be coinciding. If no object is placed, the 0 of the circular scale, that is CSZ, the 0 of the circular scale is supposed to coincide with the reference line. So there will be no 0 error, no 0 correction. But if you are rotating it in such a way that it was already ahead, already in the anti-clockwise sense, so you are going to call it leading, already leading. If it is already leading, that is, you will say it will be rotated less, traveling less, but reading more. Traveling less, but reading more. Which means it is actually measuring less, but the reading given is more. So if the reading given is extra, how to compensate that? Subtract it. But you are measuring something, but the reading, the red value is actually greater than the actual value. How to compensate that lead? Obviously you have to subtract. So you will say here 0 correction, because you are going to compensate by 0 correction. 0 correction is going to be negative and 0 error is going to be positive. So 0 correction is going to be negative and 0 error is going to be positive. I hope you got the idea, a bit of the idea of what I talked about. I talked about the types of 0 error, in which first of all I told you that if it is no leading, no lagging, then definitely you need not to think much. There will not be any compensation required. But suppose we talk about that compensation in such a way that here if that is the reference line and this time, if that is the reference line and this time you are starting not from the start but a bit lagging. So don't forget, you have to rotate the standard vernier caliper in the anti-clockwise sense. You have to rotate it in the anti-clockwise sense, but the 0 starts from somewhat clockwise. So it is already lagging. You are supposed to let it travel like this. Let it travel the readings down, down. But if it is already starting from 0, no leading, no lagging. If it is starting from already a bit of the down, which means already leading. If it was a bit above, so I will say this is already lagging. Already lagging means it is rotated more. It has to rotate more. It might rotate 11 steps, but it can show you only 9 steps because of the 2 steps lagging. So rotated more, but reading less. If it is rotating more and reading less, so I will say if it is reading less than the actual required, so compensation has to be added. Zero correction is to be positive and zero error must be negative. Zero correction must be positive and zero error must be negative. I hope that is sorted for you. All right. So I hope you got the idea of the compensatory behavior, the similar way we used to talk about in the vernier calipers. All right. Let's come back. So here I will say the main scale reading. The main scale reading is, what is this main scale reading? The way we used to define it in vernier caliper, I'll use the same language. That is that division of main scale, that division of the main scale that lies just left to the circular scale. Left to the circular scale. So I'll show you once. See, this is a proper orientation. The circular scale is being moved anti-clockwise sense, which means the scale will move towards the right. The above dotted line 3.50 mm, it is showing that division on the main scale that lies left to the circular scale. So that is the main scale reading. You can see the first place. Main scale reading 3.5. The second one is that division of the circular scale that coincides with the reference line. So 21st division of the circular scale that coincides with the reference line, but you have to multiply that 21st division with the least count. With the least count, that is you can see 0.1 mm here. So 0.01 mm here, 0.01 mm for screw gauge. So 21 should be multiplied with 0.01 mm and the final answer is also in mm. Final answer will be in millimeters. Alright. So that division of main scale that lies just left to the circular scale. This we have already obtained. Least count of screw gauge we have already obtained. What about the CSR, sir? What about the circular scale division? I will say that division, it's an easier version in comparison to the vernier calipers. This is easy. That division of circular scale that coincides with reference line. Right? So that's going to be the situation. That is going to be the situation for us. Okay. So we will see the main scale reading, that reading on the main scale which lies left to the circular scale, and then the circular scale reading, that division on the circular scale which is going to be coinciding with the, coincide with the reference line. And then we have to multiply with the least count of screw gauge. If nothing given, that remember that screw gauge standard one you can take, that is 0.01 mm. Alright. And then the types of zero error or zero correction, the same way in vernier caliper, you have to remember here, zero correction is algebraically added, zero error is algebraically subtracted, minus. Okay. Zero correction will give you a compensatory behavior. If you are already leading, the readings will be big, subtract them for the compensation. Error will be positive. Okay. If you are already lagging, you are giving a lesser value, then compensation requires some support. You have to add the correction or compensation. Error will be naturally, algebraically opposite of it. That's why it is negative. Hope the very idea of this device is clear. Why do we study that? Why we are learning how to take the reading? Okay. Understood? But sir, yes, definitely better understanding will be developed if we go through the problems. So let me take few more problems for you. First question. So a screw gauge has least count of 0.01 millimeter. I'm just increasing its size. A screw gauge has least count of 0.01 millimeter. That's a standard one. Okay. And there are 50 division on its circular scale. The pitch of the screw gauge is, we can say we know that least count of screw gauge is equal to pitch by number of divisions on circular scale. They are asking you the pitch. So pitch will be equal to least count of screw gauge into number of divisions on circular scale. So least count of screw gauge is given to you, a standard one, 0.01 mm, and the number of divisions on circular scale are 50. Number of divisions on circular scale are 50. If you are going to multiply 5, it will be 0.05. Another 10, answer will be 0.5 millimeter. Millimeter, and since all the options were in millimeter, hence second option is the true one. Hope the problem was very easy. This was obviously intentionally given. It is one of the most basic models just to check whether even you know the screw gauge or not. Okay. So knowing the syllabus, even knowing the headings and the topics in the syllabus is also some sort of preparation. Okay. So you must be knowing it. Just have a look. We are moving ahead. All right. All right. So I'm taking the next one. In 4 complete rotations, I think the size can be enhanced a bit. In 4 complete rotations, the distance moved by the screw on the linear scale is 2 mm. Okay. So what they are giving is 4 complete rotations. 4 rotations are giving you how much? They are corresponding to 2 mm. If 4 rotations are corresponding to 2 mm, this implies one rotation will correspond to 2 mm by 4, which means 0.5 mm. And don't forget, whatever is the linear distance that could be that is traveled in one complete rotation, this is said as pitch. This is basically the pitch. I repeat, the distance traveled in one complete rotation is called pitch. Its circular scale contains 50 divisions. What next, sir? Its circular scale contains 50 divisions. NCS contains 50 divisions. Number of divisions on circular scale is 50. Find the least count of the screw gauge. So naturally what you can say? Least count of the screw gauge is pitch by number of divisions on circular scale. So pitch is given as 0.5 mm by 50. So naturally if I do 0.5 by 5, I will get 0.1. But since it is 50, it is 0.01 mm, or you can say 10 to the power minus 5 meter. Again, like a standard one only. So 0.01 mm. 0.01 mm. Option B is correct. Hope that is easy. Another model, instead of giving directly the pitch, they are telling you so much of distance in so many revolutions. But do remember, you are not interested in n number of revolutions. You are particularly interested in one revolution. That's what it happened. Okay. I hope that's clear, and don't worry, don't be in a rush to copy down everything. Notes will be separately provided, so not to worry regarding anything. Okay, chaliye. Just look at it like a movie so that you can understand the theme. Once you understand the theme, you can make use of notes by looking at the problem and give it a shot of trying it on your own. Then for your convenience, you can still refer to the solution provided. All right, next problem. We are going to take 10 of them here. We are going to take 10 of them. Now we are at example 3. Now in example 3, what is happening? In a screw gauge, 5 complete revolutions. See, similar kind of model. 5 complete revolutions of the screw cause it to move a linear distance of 0.25 centimeters. So I will say 5 rotations. 5 rotations will correspond to 0.25 centimeters. This implies one rotation will correspond to how much here? That will be 0.25 by 5, or that can be written as 0.05 centimeters. 0.05 centimeters. Why you should not change it into millimeters, sir? Because you see all the 4 options are in centimeters. Though we should be changing on in a standard mode, we should be changing it into millimeter. But that will depend on options, no? Since all the options are in centimeters, let's keep it this way. Okay. So this is 0.01 centimeters, and we can say that's going to be a pitch. Okay. Now, there are 100 circular scale divisions. What else? There are 100 circular scale divisions. NCS, that is 100. From where what information can be retrieved, sir? We can retrieve the information of least count. Least count of screw gauge, that is pitch by number of divisions on circular scale. Pitch is how much? That is 0.05. 0.05 centimeters by 100. Oh my God. So the answer is going to be very, very big. 2 decimal places were already there. Now you have to put 2 more. So 0.0005 centimeters. 0.005 centimeters. 2 decimals were already there. Because of the 100 in the denominator, you are supposed to keep 2 more. Hope everything is cool. Everyone is cool with the calculations involved. Okay. Now they are saying further. Let me take the story one phase ahead. Problem number 1, problem number 2, we learned something. We implemented our gained knowledge till now. Now what is happening? The thickness of a wire measured by the screw gauge gives a reading of 4 main scale divisions. 4 main scale divisions and 30 circular scale divisions, assuming negligible zero error, no zero error. The thickness of the wire is, so I will take that separately. Main scale reading. Main scale reading is basically 4 main scale divisions. 4 main scale division. But you need to understand that pitch, once you move a complete rotation, a pitch. This can also be taken as MSD, main scale division, size of MSD. So basically pitch means you have completed one rotation, how much the screw gauge will travel, how much the circular scale will travel. So whatever rotation the circular scale will travel ahead in one complete rotation, how much is whatsoever the circular scale will travel ahead, that distance should be mentioned as a division on the main scale, the reference scale. So I can also say that pitch can be taken as MSD, another point to be learnt from here. So for the pitch you have calculated as 0.05 centimeters. So that's gonna be 0.2 centimeters. That's 0.2 centimeter. Next is the circular scale reading, circular scale division. So we can say reading can be taken as main scale reading plus least count of screw gauge into circular scale reading CSR minus zero error. But here zero error is given to be 0, likha hai, it is written negligible zero error. So main scale reading, what is the main scale reading? That is 0.2 plus least count of screw gauge you have calculated 0.0005, okay, and that is 30 main scale divisions, 30 circular scale divisions, so that is 0.2 plus, since it is 30, 1 0 will compensate here, so that is 0.00, okay, and 5 into 3 that will be 15, and this will be the value if you multiply it with 30, but if you multiply it with 3, then that's gonna be 0.015. So the final answer is 0.2150 centimeters. You can also write it as 0.0150. Ultimately, this is your answer. Okay. So the final answer is option D. I hope you got the idea. Basic calculation. Still, every basic calculation I'm doing it for you. But do remember, in the first question, what we have learned? In the first question, we have learned only to review the basic formula. Least count is equal to pitch by number of divisions on circular scale. In the second question, we have given ourselves the reminder that the pitch is not the total distance traveled. The pitch has to be the distance traveled in one rotation. So if it is given in one rotation, that's fine. Not given in one rotation, calculate it for one rotation. And in the next time, we have seen in the next question, what is our learning? That the pitch can also be taken as the main scale division. I hope step by step, we are learning a lot. Okay. And whatever I am teaching you, whatever models we are discussing in this interaction, exam will not be bringing any new model or other than that. Okay. So just have a look and don't rush to copy the things. Notes will be separately provided. All right. I hope we have gone through it also. Quickly, let's move on the next one. That is example 4. Seems to be a simple one. The least count of the main scale of a screw gauge. Least count of the main scale is 1 mm. Least count of the main scale, or that is also called as MSD. Least count of the main scale, or that is also called as MSD. and now we know that is also called as pitch. Pitch, just now in the previous problem we have learned that is equal to 1 mm. 1 mm. The minimum number of divisions on the circular scale. What is the number of divisions of circular scale? So that we want to measure 5 micrometer diameter. We want to measure 5 micrometer diameter. Okay. So how to talk about it? We want to measure 5 micrometer. We will say the least count of screw gauge. Least count of screw gauge, which is pitch 1 mm by number of divisions on circular scale. Number of divisions on circular scale, that is given as 5 micrometer. 5 micrometer. Okay. From here, if I want to solve it, see what I can do. From here, if I want to solve it, I will say pitch is 1 mm, 10 to the power minus 3 meters by number of divisions on circular scale. That is equal to 5 micrometers. So 5 into 10 to the power minus 6 meters. From here, n on circular scale will be 10 to the power minus 3 by 5 into 10 to the power minus 6. So that's gonna be 10 to the power 3 by 5, means 1000 by 5. 1000 by 5 definitely, 1000 by 5 definitely it is going to be 200. And hence these were the 200 number of circular divisions. 200 number of circular scale divisions should be available. And hence the answer is going to be 200. So again, what we have seen is least count of main scale. What is our learning from this problem? Least count of main scale is also called as MSD, main scale division, can also be taken as pitch here. I hope that's clear for you. All right, let's talk about another model now. Another model is this. So this was a recent question from one of the test series I was referring to for you people. All right, so what is that exactly? The accompanying diagram represents a screw gauge. That's a screw gauge diagram in which, if that is visible to you, the 31st division, 30 and next to it, 31st division coincides with the reference line. The circular scale is divided into 50 divisions and the linear scale is divided into millimeters. So what is given to you as of now? What is given is circular scale is divided into 50 divisions. Number of circular scale division is 50 and the linear scale is divided into millimeters, means one main scale division or least count of main scale or pitch that is equal to 1 mm. Millimeters means 1 mm, calibrated into millimeters 1 mm. If the screw advances by 1 mm when the circular scale makes 2 complete revolutions. No, that's not given. The idea is that we have millimeters, but the twist in the story is that this time in one complete revolution 1 millimeter is not read. The screw advances by 1 millimeter when it takes 2 complete revolutions. So I will take the logic back that okay, it is available generally as 1 mm, but this time they are precisely mentioning that you have to take 2 complete revolutions. So calling this here is wrong in this problem. For this problem, this is wrong. But we will write it, we will remember this so that the same mistake should not be happening in the exam. So yes, whatever we have done in the previous question, that's correct. But the same logic if we are trying to apply here, that's something inappropriate. The reason is examiner is telling you that yes, I have it in millimeters, but still I'm giving you that 2 complete revolutions will actually be making it capable, making the circular scale capable to exceed or to advance by 1 millimeter. So rather the correct information is, I will say that 2 rotations will correspond to 1 mm or 1 rotation will be corresponding to 1 by 2 means 0.5 mm. This can be treated as a pitch. Okay, this can be treated as a pitch. The least count of the instrument is finally least count of the instrument. Finally, least count. So I will say least count of screw gauge is given by pitch by number of divisions on circular scale. So pitch is how much? 0.5 mm. Number of divisions on circular scale is 50. 0.5 by 5 would have been 0.1. Since it is 50, it is 0.01 mm But do remember, might happen that all the options are in centimeters. So please be prepared. It is 0.001 centimeter or eventually 10 to the power minus 5 meters. Kind of standard vernier caliper. Exactly the standard vernier caliper. You can see that. A standard one. Hope you got the idea. All right. So every problem model, we are trying to learn something new. We are also trying to see what could have been a silly mistake. See, I'm writing exactly in front of you for your notes that do remember the mistakes which you have already made. Do remember the silly things which you have done as a blunder in the exam. So if you remember your mistakes, having a collection of our own mistake is very much useful, as I always say. If you remember your mistakes, trust me, those mistakes will not be repeated again. Otherwise, there might be a probability. Okay. So now taking you one step ahead, the diameter of a wire is measured as 0.25 centimeter using a screw gauge of least count something. The percentage error is percentage error. Here we will say percentage error will be equal to the mean absolute error, suppose the delta D by D naught true value into 100. So the mean absolute error or inaccuracy in the measurement, the mean absolute error, you can call it mean absolute error. You can also call it inaccuracy in measurement. Inaccuracy in measurement. And similar problem we have taken in vernier calipers. You can also call it least count of the device. So here it is going to be the least count of screw gauge. Okay. So delta D is how much given to you? 0.005 centimeters and it is 0.25 centimeters into 100. So if you multiply this 0.005 into 100, I suppose it will be one decimal shift, another decimal shift, it will be 0.50 centimeter. I mean 0.50 by 0.25, or it is going to be 2%. Answer is going to be 2%. All right. So this is how you can, again, what information we have learned from here is that the delta D, the mean absolute error, can be taken as the inaccuracy of the measurement, or you can say the least count of the device used. I think that's fine for you. Another problem. Example 7. The pitch and the number of divisions. The pitch and the number of divisions on the circular scale for a given screw gauge are given to you. So definitely for pitch and number of divisions, you can find out the least count. So let's keep doing it. Okay. Let's keep doing it. So the pitch is given as 0.5 mm. The number of divisions on circular scale is given to you as 100. So definitely the least count of the screw gauge will be pitch by number of divisions on circular scale. And since for all the four options are in mm, something is in meter also, I suppose it should be in millimeter. I'll just edit the options. I think it should be millimeter here, millimeter here. All the four options are to be in millimeter. Is it fine? All the four options are in millimeter. Let's see what is that exactly. So here it is pitch by number of divisions. So that is going to be 0.005 mm. 0.005 mm. At least the first line of the question tells you this much. Next is when the screw gauge is fully tightened. When the screw gauge is fully tightened means we are about to talk about the zero error. Fully tight. No object is in between. Without any object. The zero of its circular scale lies 3 divisions below the mean line. Means the situation is somewhat like this. That this is the reference line. This is the reference line. And this is the circular scale which is about to rotate like this. Circular scale. The zero of the circular scale lies 3 divisions below the mean line. Below the mean line. 0. So can I say it is already ahead? If it is already ahead, which means it will be traveling less, rotated less, but reading more. Rotated less, but reading more. If it is reading more, so compensation should be, subtracted. I mean, whatever is the requirement, it is reading more than that. So correction, compensation, zero correction should be subtracted, negative, and zero error must be positive. Zero error must be positive. I hope you got the idea of the nature. Traveling more, traveling less, reading more, because it was already leading. So traveling less, but reading more. If it is reading more, compensation should be negative, zero correction, compensatory term should be minus, and error should be naturally positive. Okay. So how to calculate that? Here, I'll calculate the zero error. Zero error, obviously that is to be positive. Zero error, that is to be positive, because that's a more common term. Why? That's why I'm not starting with correction. Anyways, remember, zero correction is algebraically added and zero error is algebraically subtracted. So that is positive of 3 divisions into the least count of screw gauge. Why, sir? Because it should be in measurement. It should be in measurement, in units, and not in divisions, not in terms of divisions. So if they give you in terms of units, millimeter or centimeter, you should be directly taking it. But if they are giving you the same, that in terms of division, then definitely after commenting positive or negative, you should be multiplying it with the least count of screw gauge. Least count of screw gauge, that is 0.005 mm. The same thing we used to do in vernier caliper. Yesterday we also did the same thing. So 0.005 millimeters. All the 4 options are like that. So it will be positive of 0.015 millimeter. Positive of 0.015 millimeter. Now what they are saying? Now let us talk about the reading. Now it's the turn of taking the reading. Reading is MSR plus least count of screw gauge into CSR minus zero error. So the readings of the main scale are 5.5 mm. Dekho, main scale reading is 5.5 mm. The circular scale reading is 48 respectively, and they are asking you the thickness. Okay, so that's what we got. Main scale reading is 5.5 mm millimeter plus least count of screw gauge is 0.005 mm. Circular scale reading is 48 minus zero error is, just now you have calculated, it is positive of 0.015. Okay, so what you got is 5.5 plus, I'll add that. So I will say 8, 5, 40 and 5, 4, 20. I think 24 we are getting. So 0.24. 48 into 5 is going to be 240. So I will get 0.24 here and then minus of 0.015. So now let's do it carefully. 5.5 plus 0.24, that's going to be 5.74. 0 minus 0.015, and you can do the subtraction. So I think 5.7, 40 minus 15 is 25. This much of mm, 5.725 mm, and hence option D is correct. Option 4. I hope you are good with each and every step. See, whatever I taught previously, I'm taking the help of problem to tell you, and whatever model I have discussed with you, be specific, be comfortable. Maximum in the exam, this is going to be the story. Just see that once again. Take a minute. I'll wait for you. Take a minute to see that you are mapping each and every sentence of the question and the phases. Okay. First sentence, we calculated least count. Next sentence, we commented the positive and negative. Next sentence, we calculated the reading, like that. See that once. Take your time. Copy the notes later. Take your time. All right. I hope you have noticed everything. Chaliye. So 70% of our journey is already completed. We are at example 8. Okay. So that is 2 full turns of the circular scale of a screw gauge covers a distance of 1 mm on its main scale. So what is the first information given to you? 2 full turns of the circular scale means 2 rotations are reading 1 mm on the main scale. First line, This implies one rotation will correspond to 0.5 millimeter, and this 0.5 millimeter can be called as a pitch. The total number of divisions on the circular scale is 50. Number of divisions on circular scale is 50. So by these two information, definitely you can calculate the least count of screw gauge, that is 0.5 pitch by number of divisions on circular scale, that is 50, and hence answer is 0.01 millimeters. 0.01 millimeters, and let's see, all the four options are in millimeters, so we are comfortable with mm only. Okay. Further, it is found that the screw gauge has a zero error of 0.03 mm. It is already given here. Zero error is already given negative. So it's a simpler version of what we have seen earlier. It is relatively simpler. You don't have to think positive, negative. You don't have to find out in terms of mm. It is already given in terms of mm. If it would have been given in terms of divisions, then we will multiply it with the least count and we will get it in terms of mm. Okay. Now, while measuring the diameter of a thin wire, a student notes that the main scale reading of 3 mm and the number of divisions on the circular scale is 35. The diameter of the wire is, it's going to be easy this time. I will say reading of diameter. A good problem model could have been that they are giving the readings of the diameter, but they are asking you the radius. That's what, if you remember the last problem model of vernier calipers we have done. Okay. So there were also, I have discussed 10 different models with you. Here also we are doing the same. So if they ask you the radius, don't forget to do the half in the final step. Okay. So reading of diameter is main scale reading plus least count of screw gauge into CSR, circular scale reading, and minus zero error. So main scale reading is how much? The main scale is reading 3 mm. 3 mm. Let's keep it in mm only because all the four options are likewise. Least count of screw gauge already in mm, 0.01 mm. So CSR will be in terms of division, that is in line with the main scale as 35 minus, it is given as 0.03, already given as minus of 0.03. So mm, don't forget that this is also in mm. So zero correction is algebraically added, but zero error is algebraically subtracted. So that is 3 plus, if you multiply that, you will get 0.35, minus will be plus, and it will be 0.03. So what you got is 3.38 millimeter. 3.38 millimeter. Again the fourth option is going to be the correct one. Exact calculation is in front of you, and I don't think you need a lot of time to understand this because it was relatively a simpler version of exactly the previous question, that is example 7. Hai na? Hope that's cool and clear. Let me take you towards the last two problem models. So this is one of the problems. A screw gauge gives the following reading when used to measure the diameter of a wire. So main scale reading is something, circular scale reading is something. Given that 1 mm on the main scale corresponds to 100 division of the circular scale. The diameter of the wire from the above data is. So first thing is, we can say 1 mm on main scale corresponds to 100 divisions on the circular scale. I can call this 1 mm. 1 mm on main scale. If nothing is given, you can take it as MSD. Corresponds to 100 divisions on circular scale. Alright. So I will say the least count of screw gauge that can be pitch by number of divisions on circular scale. You can take this as the pitch or 1 MSD. So that's going to be 1 millimeter. All the four options are in centimeters, so don't forget that, by 100. So that will be 0.1 centimeter by 100. So that will be 0.001 centimeters. 0.001 centimeters. That's what you got. Okay. Now they are saying circular scale reading is 52 divisions. Finally, reading will be equal to MSR plus least count of screw gauge into CSR minus zero error. If nothing is mentioned regarding the zero error, nothing is mentioned regarding the zero error, for the sake of simplicity, assume it to be 0. Main scale reading is 0 mm, so obviously it will be 0 centimeter only. Plus least count is 0.001 centimeters. And they say the CSR is 52 divisions, 52 divisions. So the final answer is 0.052 centimeters, 0.052 centimeter. It was a simpler version relatively, 0.052 centimeters. I hope you got the idea, and I hope you are enjoying and have understood the 90% of the journey, because with the next problem you are going to put a closure on circular screw gauge. But don't worry, I have brought all the experimental skills for you one by one. You just enjoy the learning. Okay, but yes, breaks are necessary. Whenever you are doing a particular session, after that you should take a break, then see the class notes, go through them thoroughly, put a revision closure, and then only go to the next one. Okay, all the relevant related problems I am covering it, so you need not to practice with many other sources, books, test papers, this, that, not required at all. Focus much on the revision. All right, chaliye, taking you towards the last problem of the day. That is a similar one to the previous. Just to sum it up, it is a review problem. It will contain everything you have learned till now. Okay, so what does it say? First of all, a student measured the diameter of a small steel ball using a screw gauge of least count. Screw gauge least count is 0.001 centimeters. So least count of screw gauge is 0.001 centimeters, and all the 4 options are in centimeters, so I'm not going to do anything with it. The main scale reading is 5 mm. MSR is given to you as 5 mm, or you should be writing it as 0.5 centimeters, because the options are like that. 0 of the circular scale division coincides with 25 divisions above the reference level. So I will say the CSR is given 25 divisions. What else? If screw gauge has a zero error of minus of 0.004 centimeters, then correct diameter of the ball is. So you will say here reading of diameter. Remember, I told you that option first could be of diameter, but actual question could have been for radius. So be prepared accordingly. Reading of diameter will be equal to simple. I'll conclude with this: MSR plus least count of screw gauge into CSR minus 0 error or plus 0 correction. Okay. MSR is already given 0.5. All the terms should be in centimeters. Plus least count is given in centimeters, that is 0.001 centimeters. So CSR should be in terms of number of division, that is already given as 25, minus of negative error, that is minus 0.004. So what you have got is 0.5 plus 0.025 minus plus 0.004. So the final answer is 0.529 centimeters. See, one decimal place, another decimal place, 5 plus 4, 9, the third decimal place. So that's how you can simply do the calculation. You got option A, 0.529 centimeters. Hope the basic idea is clear. So this is how you can do all the problems of screw gauge and vernier caliper. And I hope with these first 2 experiments, you have put a closure on the last round of your preparation regarding this topic. And very soon we are going to meet with the third application, third experimental skill. Till then, all the best. Bye.